This video will cover different methods for representing urban areas with buildings and other features that obstruct or impact the movement of water in an SRH-2D model using SMS. Urban areas present a unique challenge to assigning roughness values to hydraulic models due to the many different types of land use, including buildings, that impact hydraulic results. Like other model parameters, it is important to understand what the application of the model will be so the appropriate approach can be used to represent buildings. The example project site used in this video includes a river flowing west to east, a primary road and bridge crossing running north and south, and a developed floodplain with various buildings and other obstructions. The topography is generally flat with some minor variation throughout the model domain. This area is also in a FEMA-mapped floodplain. The first method for representing buildings is to create a single material type and associated Manning's in value for an urban area. The impact of buildings in this area is essentially averaged across the entire region. The Manning's in value used for the composite area should be based on engineering judgment and take into account prevalent ground cover and amount and type of obstructions. This approach provides a simplified method to account for hydraulic roughness over a large area using a less refined mesh. This method does not capture flow variations along roads and around buildings. This approach is adequate to represent larger areas where detailed hydraulic results are not necessary. If more detailed hydraulics are required, or if the urban area is in close proximity to the project area of interest, a more detailed representation of the buildings may be warranted. The second method is to increase mesh resolution and represent buildings with an unassigned material type. This approach requires building footprints to be created by the engineer or imported. However, it does not necessitate representing each building in the mesh geometry. The unassigned material type assigned to the mesh approximately represents the building area depending on the mesh refinement. Remember that however detailed material zones are, they ultimately get assigned to individual mesh elements, so the representation of buildings using this method will depend on the mesh resolution. Manning's in values used for the surrounding area should be based on engineering judgment and take into account prevalent ground cover and other obstructions, but not the buildings. The Manning's in value used in this approach will be less than the first approach. This approach allows for an approximate representation of flow patterns around buildings and provides a more detailed hydraulic result in urban areas. The third and most detailed method involves representing the buildings in the mesh geometry. The buildings can be represented as holes in the mesh or could also be unassigned material types depending on the purpose of the analysis. Manning's in values used for the surrounding area would likely be similar to the second approach. This more detailed approach requires more time to develop appropriate mesh geometry and results in a larger, less efficient model. However, this approach provides the most detailed representation of hydraulics around buildings and is the best approach for projects requiring insight into detailed hydraulics at specific urban locations. For this example, using the detailed mesh as the control, with a dense urban area in value of 0.08, the second approach calibrated to a similar in value of 0.08, and the first approach calibrated to an in value of 0.1. These calibrations took into account water surface elevation and flow split discharges. However, neither approach matched the detailed mesh results exactly. All three methods have varying levels of detail that could be adjusted depending on the purpose of the analysis. It is important to understand the application of the model to select the most appropriate approach to representing buildings in urban areas.